Information Technology: Essentials and Management of Information Systems. Written by Phil Gilberts. Narrated by Kevin Brooker. Part 1. Essentials of Information Technology. 1. Introduction to Information Technology. Information technology, or IT, refers to the use of computers, software, and networks to manage, process, store, and communicate information. It encompasses a broad range of activities and applications, including hardware and software development, network design and management, data storage and analysis, and cybersecurity. At the core of IT are several key components. Hardware consists of the physical components of computers and related devices, such as servers, desktops, laptops, smartphones, and networking equipment like routers and switches. Software refers to the programs and applications that run on this hardware, which can be categorized into system software like operating systems and application software like word processors and database management systems. Networks are systems that connect computers and other devices to share resources and information, including local area networks or LANs, wide area networks or WANs, and the Internet. Data management involves the processes and technologies used to collect, store, and analyze data, encompassing databases, data warehouses, and big data analytics. Cybersecurity is the practice of protecting IT systems and data from cyber threats through measures like firewalls, encryption, and intrusion detection systems. Additionally, IT services support the use and maintenance of IT systems through technical support, IT consulting, and managed services. IT is crucial for efficiency and productivity, as it enables automation and streamlines processes across various industries. It also plays a vital role in communication, facilitating methods like email, instant messaging, video conferencing, and social media. In terms of data management, IT provides tools for storing, retrieving, and analyzing large volumes of data, which supports informed decision-making. IT drives innovation by enabling the development of new products, services, and business models. And it fosters global connectivity by allowing businesses and individuals to connect and collaborate across the globe. The field of IT offers diverse career opportunities, including roles such as software developer, network administrator, systems analyst, IT manager, cybersecurity specialist, and data scientist. Understanding IT is essential in today's digital age, as it impacts nearly every aspect of modern life and business. Overview of Information Technology. Information technology, or IT, is the field focused on the use of computers, software, and networks to manage, process, store, and communicate information. It plays a critical role in modern society, impacting various aspects of both personal and professional life. At its core, IT involves several components. The importance of IT lies in its ability to enhance efficiency and productivity by automating and streamlining processes across various industries. IT facilitates communication through tools like email, instant messaging, video conferencing, and social media, making global connectivity and collaboration possible. It also provides robust data management capabilities, enabling the storage, retrieval, and analysis of large data volumes for informed decision-making. Moreover, IT drives innovation by supporting the development of new products, services, and business models. It offers a wide range of career opportunities, including positions such as software developer, network administrator, systems analyst, IT manager, cybersecurity specialist, and data scientist. In today's digital age, a thorough understanding of IT is essential as it influences nearly every facet of modern life and business. History and evolution of IT. The history and evolution of information technology, or IT, trace a journey from simple mechanical systems to sophisticated digital networks that permeate every aspect of modern life. The development of IT can be segmented into several key phases. Early beginnings. The foundations of IT began with basic mechanical devices. One of the earliest examples is the abacus, used for calculations as far back as 2400 BC. In the 17th century, Blaise Pascal and Gottfried Wilhelm Leibniz developed early mechanical calculations. 19th century. The 19th century saw significant advancements with Charles Babbage's conceptualization of the analytical engine, a mechanical general-purpose computer. Ada Lovelace, working with Babbage, created what is considered the first algorithm intended for a machine, marking her as the first computer programmer. Early 20th century. The early 20th century introduced electromechanical computing. Devices like the punched card machines developed by Herman Hollerith for the 1890 U.S. Census laid the groundwork for future data processing. Alan Turing's theoretical work in the 1930s established the principles of modern computing, including the concept of a universal machine capable of performing any computation. Mid-20th century. The 1940s and 1950s marked the advent of electronic computers. The ENIAC, or ENIAC, developed in 1945, was one of the first general-purpose electronic computers. The invention of the transistor in 1947 by Bell Labs revolutionized computing, leading to smaller and more efficient machines. The 1950s also saw the development of high-level programming languages, with Fortran, or Fortran, being introduced in 1957. 1960s to 1970s. The 1960s and 1970s witnessed the rise of mainframe computers, used primarily by large organizations for bulk data processing. The development of integrated circuits further miniaturized and enhanced computer capabilities. During this period, ARPANET, or ARPANET, the precursor to the Internet, was created, enabling early forms of digital communication. 1980s. The personal computer, or PC, revolution began in the 1980s, making computers accessible to the general public. Key products like the Apple II, IBM PC, and Microsoft's MS-DOS operating systems were launched. The Graphical User Interface, or GUI, popularized by the Apple Macintosh and later by Microsoft Windows, made computers user-friendly. 1990s. The 1990s saw the explosion of the Internet, transforming IT into a global phenomenon. Tim Berners-Lee invented the World Wide Web, making information easily accessible. E-commerce emerged, and businesses began to embrace IT for various applications. The development of email, search engines, and browsers transformed communication and information retrieval. 2000s to present. The 21st century has been characterized by rapid advancements in IT. Mobile technology, including smartphones and tablets, has revolutionized how people access information and communicate. Cloud computing has enabled scalable and flexible IT resources. Social media platforms have transformed personal and business interactions. Big data and analytics, artificial intelligence, and machine learning have become critical components of IT, driving innovation across industries. Cybersecurity has become a crucial focus as digital threats have grown more sophisticated. In summary, the evolution of IT from mechanical calculators to advanced digital networks underscores its integral role in shaping the modern world. Each phase of development has built upon previous advancements, leading to the complex and dynamic IT landscape we experience today. The role of IT in modern organizations. Information technology, or IT, plays a pivotal role in modern organizations, influencing nearly every aspect of their operations. The integration of IT into business processes has transformed the way organizations function, compete, and deliver value. Here are some key areas where IT significantly impacts modern organizations. Operational efficiency. IT enhances operational efficiency by automating routine tasks, streamlining workflows, and optimizing resource management. Enterprise resource planning systems, or ERP systems, for instance, integrate various business processes such as finance, human resources, and supply chain management into a single cohesive system, improving coordination and productivity. Communication and collaboration. Effective communication and collaboration are essential for any organization. IT facilitates this through various tools and platforms such as email, instant messaging, video conferencing, and collaborative software like Microsoft Teams and Slack. These tools enable real-time communication, remote work, and collaboration across different geographic locations, breaking down traditional barriers to teamwork. Data management and analytics. Organizations generate vast amounts of data. IT provides the tools and technologies for managing, storing, and analyzing this data. Databases, data warehouses, and big data analytics platforms help organizations make sense of their data, enabling data-driven decision-making. Business intelligence tools, or BI tools, transform data into actionable insights, helping organizations identify trends, optimize operations, and predict future outcomes. Customer Relationship Management, or CRM. CRM systems help organizations manage interactions with current and potential customers. These systems collect and analyze customer data, providing insights that help in personalizing marketing efforts, improving customer service, and increasing sales. IT solutions such as Salesforce and HubSpot are widely used to enhance customer relationships and drive business growth. Innovation and competitive advantage. IT is a driver of innovation, allowing organizations to develop new products, services, and business models. By leveraging emerging technologies like artificial intelligence, machine learning, and blockchain, organizations can create unique value propositions and gain a competitive edge. IT also enables rapid prototyping and agile development, fostering a culture of continuous improvement and innovation. Cybersecurity. With the increasing reliance on digital systems, cybersecurity has become a critical concern. IT provides the tools and practices necessary to protect organizational data and systems from cyber threats. This includes firewalls, encryption, intrusion detection systems, and comprehensive cybersecurity strategies. Ensuring the security of sensitive information helps maintain trust with customers and stakeholders. Financial management. IT systems play a crucial role in financial management. Accounting software and financial management systems automate financial processes, ensuring accuracy and compliance. These systems help in budgeting, forecasting, financial reporting, and monitoring financial performance, providing a clear picture of the organization's financial health. Supply chain management. IT improves supply chain management by providing visibility and control over the entire supply chain. Technologies like RFID, GPS, and Internet of Things devices enable real-time tracking of goods and inventory management. Supply chain management software helps optimize logistics, reduce costs, and improve delivery times. Human resource management. Human resources departments benefit from IT through systems that manage employee information, recruitment, payroll, performance evaluation, and training. Human capital management systems streamline human resources processes, improving efficiency and employee satisfaction. Regulatory compliance. IT helps organizations comply with regulatory requirements by automating compliance processes, maintaining accurate records, and ensuring data integrity. Compliance management software assists in tracking regulatory changes and implementing necessary controls to avoid legal issues and penalties. In conclusion, IT is integral to the functioning of modern organizations, enhancing efficiency, enabling innovation, improving decision-making, and providing competitive advantages. By leveraging IT, organizations can adapt to changing market conditions, meet customer demands, and achieve their strategic goals. 2. Hardware and software fundamentals. Let's talk about some hardware and software basics in this chapter. Understanding computer hardware. Understanding computer hardware involves exploring the physical components that make up a computer system. The central processing unit, or CPU, is the core of the system, often referred to as the brain of the computer. It performs calculations, executes instructions, and manages data processing tasks. Another essential component is memory, which includes both random access memory, or RAM or RAM, and storage devices. RAM provides temporary storage for data and instructions that the CPU needs to access quickly, while storage devices like hard disk drives, or HDDs, and solid-state drives, or SSDs, store data permanently. The motherboard is the main circuit board that connects all hardware components, allowing them to communicate with each other. It houses the CPU, RAM, and expansion slots for additional components such as graphics cards and networks cards. The power supply unit, or PSU, converts electrical power from an outlet into usable power for the computer, distributing it to various components. Input devices such as keyboards and mice allow users to interact with the computer, while output devices like monitors and printers enable the computer to convey information to the user. Peripheral devices, including external drives, webcams, and printers, expand the functionality of the computer. Graphics processing units, or GPUs, are specialized hardware designed to handle rendering images, videos, and animations. They are particularly important for tasks that require high graphical performance, such as gaming, video editing, and graphic design. Understanding these hardware components is crucial for diagnosing issues, performing upgrades, and optimizing computer performance. Each component plays a specific role, and their seamless integration is what allows a computer to function efficiently and effectively. Types of software: system and application software. Software is broadly categorized into two main types: system software and application software. Each type serves distinct purposes and functions within a computer system. System software acts as a bridge between the hardware and the user, providing the necessary environment for application software to run. It includes 1. Operating systems, or OS. The most crucial type of system software. Operating systems manage hardware resources and provide common services for application software. Examples include Windows, Mac OS, Linux, and Android. The OS handles tasks such as memory management, process scheduling, file management, and input or output operations. 2. Device drivers. These specialized programs enable the operating system to communicate with hardware devices. Each device, such as a printer, graphics card, or network adapter, requires a driver to function properly. Drivers translate the OS's generic instructions into device-specific commands. 3. Utility programs. These are system management tools that perform maintenance tasks such as disk cleanup, antivirus scanning, and data backup. Utilities help keep the system running smoothly and securely. 4. Firmware. Low-level software stored on hardware devices themselves, firmware provides essential control functions for the hardware. It is often found in embedded systems like routers, keyboards, and BIOS or UEFI firmware in computers. Application software enables users to perform specific tasks and activities. It is built on top of system software and includes 1. Productivity software. These programs help users accomplish various tasks efficiently. Examples include word processors or Microsoft Word, spreadsheets like Excel, presentation software like PowerPoint, and database management systems like Access. 2. Multimedia software. Used for creating, editing, and viewing multimedia content, this category includes photo editors like Adobe Photoshop, video editors like Final Cut Pro, and media players like VLC. 3. Internet browsers. Programs like Google Chrome, Mozilla Firefox, and Safari allow users to browse the internet, access websites, and use web applications. 4. Communication software. Facilitates communication between users through email, Microsoft Outlook, instant messaging like Slack, and video conferencing like Zoom. 5. Games and entertainment software. Includes video games and other entertainment applications that provide interactive experiences such as streaming services like Netflix and music players like Spotify. 6. Business software. Tailored to meet the needs of specific business functions, this includes customer relationship management like CRM systems like Salesforce, enterprise resource planning or ERP systems like SAP or SAP, and accounting software like QuickBooks. 7. Educational software. Designed for teaching and learning purposes, this includes language learning apps like Duolingo, virtual classrooms like Google Classroom, and interactive learning tools like Khan Academy. Understanding the distinction between system software and application software is fundamental to grasping how computer systems operate and how different programs interact within these systems. System software provides the foundational layer that allows application software to function, enabling users to perform a wide range of tasks on their computers. 3. Networking and communications. Networking and communications refer to the systems and technologies that enable computers and other devices to connect and share information. These technologies form the backbone of the modern digital world. Basics of networking. Networking is the practice of connecting computers and devices to share resources and information, forming the backbone of the modern digital world. There are various types of networks, including local area networks or LANs, wide area networks or WANs, metropolitan area networks or MANs, and personal area networks or PANs. LANs cover small areas like buildings or campuses, while WANs span larger geographic areas such as cities or countries. MANs bridge the gap between LANs and WANs, connecting multiple LANs within a metropolitan area. PANs are small networks for personal devices like smartphones and laptops. Different network topologies define how devices are connected within a network. Star, bus, ring, and mesh topologies each have their advantages and disadvantages in terms of scalability, reliability, and cost-effectiveness. Network protocols such as TCP or IP, HTTP or HTTPS, FTP or SMTP, and DNS govern communication between devices and facilitate data transmission over networks. Networking devices, including routers, switches, modems, access points, and firewalls, play crucial roles in managing and securing network traffic. IP addressing assigns unique identifiers to devices on a network, enabling data routing and communication. Bandwidth and latency are important concepts in network performance, affecting the speed and efficiency of data transfer. Packet switching breaks down data into packets for transmission over networks, optimizing resource usage. Understanding these networking basics is essential for building and maintaining efficient, reliable, and secure communication systems in both personal and professional environments. By grasping the fundamental principles and components of networking, individuals and organizations can harness the power of connected technology to enhance productivity, collaboration, and innovation. Network types and topologies. Networks encompass various types and topologies, each serving distinct purposes and offering unique characteristics. Network types. Local Area Network, or LAN, connects devices within a limited geographical area, facilitating high-speed data transfer and resource sharing. Wide Area Network, or WAN, spans larger geographic areas, connecting LANs worldwide through routers and public communication links. Metropolitan Area Network, or MAN, covers metropolitan areas or large campuses, providing connectivity for multiple LANs within a city or region. Personal Area Network, or PAN, designed for personal devices, utilizing technologies like Bluetooth and Wi-Fi for wireless connectivity over short distances. Network topologies. Store topology. All devices are connected to a central hub or switch, making it easy to add or remove devices without network disruption. Bus topology consists of a single communication line or bus to which all devices are connected, but can suffer from signal degradation and collisions. Ring topology. Devices are connected in a circular fashion, with data traveling in one direction around the ring, offering better performance than bus topologies. Mesh topology involves each device being connected to every other device, providing high reliability and fault tolerance, albeit being complex to set up. Internet and intranet technologies. Internet and intranet technologies are essential for modern communication and information sharing, but they serve distinct purposes and audiences. The Internet is a global network connecting billions of devices worldwide through standard protocols. It enables users to access a vast array of resources and services using uniform resource locators or URLs, which specify web page locations. Hyperlinks allow seamless navigation between web pages, facilitated by web browsers like Google Chrome and Mozilla Firefox. Internet services include email, file transfer or FTP, online banking, social media, search engines, and cloud computing. In contrast, an intranet is a private network within an organization, using internet technologies for communication and collaboration among authorized users. It restricts access to employees who authenticate themselves, providing a platform for internal communication, sharing information, and accessing company resources such as documents and training materials. Intranets are customizable to meet organizational needs, integrating features like employee directories, news feeds, discussion forums, and project management tools. They prioritize security with measures like firewalls, encryption, access controls, and integration with business systems like Enterprise Resource Planning, or ERP, and Customer Relationship Management, or CRM, software. While the Internet fosters global connectivity and access to online resources, intranets offer secure internal communication and collaboration tailored to organizational requirements. Wireless communication and mobile computing. Wireless communication and mobile computing are indispensable elements of contemporary technology, facilitating seamless access to information and services on the move. In wireless communication, data transmission occurs over radio waves without physical connections. Networks like Wi-Fi, Bluetooth, and cellular networks enable this connectivity. Wi-Fi provides high-speed internet access, Bluetooth connects devices over short distances, and cellular networks like 4G LTE and 5G allow for mobile communication. Various protocols, such as IEEE 802.11 for Wi-Fi and GSM/CDMA for cellular networks, ensure efficient data transmission. Security measures like encryption protocols safeguard wireless transmissions from unauthorized access. Mobile computing involves using portable devices like smartphones, tablets, and laptops to access information and services from anywhere. These devices run operating systems like iOS, Android, and Windows, optimized for touch input and mobility. Mobile apps available through online stores like the Apple App Store and Google Play Store cater to various needs, from productivity to entertainment. Cloud services enable access to data, applications, and resources over the internet, while location-based services utilize GPS for mapping, navigation, and local search. Together, wireless communication and mobile computing have transformed daily life, providing constant connectivity and access to information wherever one goes. As technology advances, these technologies will continue to shape and enhance our digital experiences. 4. Data management and databases. Data management and databases are crucial for storing, organizing, and accessing large volumes of information efficiently and securely. Data management involves the practices, architectural techniques, and tools that ensure data is accurate, available, and accessible. Introduction to data management. Data management is a comprehensive process that involves the collection, storage, organization, and maintenance of data to ensure its accuracy, accessibility, and security. Effective data management is crucial for organizations as it supports informed decision-making, enhances operational efficiency, and ensures compliance with regulatory requirements. At its core, data management encompasses various practices and tools designed to handle data throughout its lifecycle. This includes data governance, which establishes policies and standards for data usage and quality, and data integration, which combines data from different sources to provide a unified view. Data management also involves data warehousing, where large volumes of data are stored and managed, and data analytics, which extracts meaningful insights from the data. Data management is essential in the digital age, where organizations rely on vast amounts of data for strategic planning and daily operations. Proper data management ensures that data is reliable and available when needed, supporting everything from customer relationship management to financial analysis and market research. With the increasing importance of data, advanced technologies and methodologies are being developed to improve data management processes. These include cloud computing, which offers scalable and flexible data storage solutions, and artificial intelligence, which enhances data analysis and predictive capabilities. Effective data management not only helps organizations stay competitive, but also protects against data breaches and ensures compliance with data protection regulations. Database Management Systems, or DBMS. Database Management Systems, or DBMS, are software systems designed to create, manage, and manipulate databases. They provide a systematic and organized way of storing, retrieving, and managing data, ensuring data integrity, security, and accessibility. DBMSs play a critical role in various applications, from business operations to academic research, enabling efficient data handling and processing. A DBMS allows users to define data structures, store data, and perform queries to retrieve specific information. It supports various operations such as inserting, updating, deleting, and retrieving data, making it easier for users to manage large datasets. By providing a consistent framework for data management, DBMSs help maintain data accuracy and consistency across different applications and users. There are several types of DBMSs, each designed to handle different types of data and use cases. 1. Relational Database Management Systems, or RDBMS. These are the most common types of DBMS, using structured query language, or SQL, to manage data. Data is stored in tables, and relationships between tables are defined through foreign keys. Examples include MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. 2. NoSQL databases. These DBMSs are designed for unstructured or semi-structured data, providing flexibility and scalability. They are often used in big data and real-time web applications. Examples include MongoDB, Cassandra, and Redis. 3. Object-oriented DBMS. These systems store data in objects, similar to object-oriented programming languages. They are used for applications that require complex data representations, such as CAD or CAM, and multimedia applications. Examples include ObjectDB and DB4O. 4. Hierarchical and network databases. These older types of DBMSs organize data in a tree-like or graph structure, respectively. They are less common today but were used in early database applications. A DBMS offers several key features and benefits. Data independence. It separates data from the applications that use the data, allowing changes to the database structure without affecting the overall system. Efficient data access. By using indexes, query optimization, and caching, a DBMS can retrieve data quickly and efficiently. Data integrity and security. It ensures data accuracy and consistency through integrity constraints and provides security features like user authentication and access control. Backup and recovery. A DBMS provides mechanisms for data backup and recovery, protecting against data loss and corruption. Concurrent access. It allows multiple users to access the database simultaneously without conflicts, ensuring data consistency and isolation. DBMSs are foundational to modern data management, supporting a wide range of applications and services. They enable organizations to store vast amounts of data efficiently, provide powerful tools for data analysis, and ensure data security and integrity. As data continues to grow in volume and complexity, the role of DBMSs becomes increasingly vital in managing and leveraging this critical resource. Data warehousing and data mining. Data warehousing and data mining are pivotal components of contemporary data management, enabling organizations to efficiently store large volumes of data and extract valuable insights from it. Data warehousing involves collecting and storing vast amounts of data from various sources into a centralized repository called a data warehouse. This repository is structured to facilitate efficient querying and analysis, providing a consistent view of organizational data that supports decision-making processes. By integrating data from multiple heterogeneous sources, such as transactional databases, operational systems, and external data sources, data warehouses ensure a cohesive and unified format. The process of extracting, transforming, and loading or ETL data ensures that it is cleaned, transformed, and organized within the data warehouse. Key characteristics of data warehouses include their subject-oriented nature, organizing data around key topics like customers, products, or sales rather than specific applications. They are also integrated, combining data from different sources into a cohesive format. Additionally, data warehouses store historical data, allowing for time-based analysis and trends, and maintain data stability, ensuring that once data is entered, it remains unchanged for consistent analysis. These features enable complex queries, data analysis, and reporting, serving as the foundation for business intelligence tools and applications. Data warehouses support activities such as trend analysis, forecasting, and decision-making by providing a comprehensive and historical view of data. In contrast, data mining is the process of discovering patterns, correlations, and insights from large datasets using statistical, mathematical, and machine learning techniques. It involves analyzing data to identify hidden relationships and trends that can inform decision-making and predictive analysis. Data mining techniques include classification, clustering, association rule learning, regression analysis, and anomaly detection. Each technique serves a specific purpose, such as classifying customer transactions, grouping similar items, identifying relationships between variables, predicting continuous values, or detecting unusual patterns. Data mining is widely used across various industries to enhance decision-making and gain competitive advantages. For example, in marketing, it helps in customer segmentation and targeted advertising, while in finance, it aids in fraud detection and risk management. In healthcare, data mining supports disease prediction and personalized treatment plans. Together, data warehousing and data mining provide a robust framework for managing and analyzing data. Data warehouses offer a stable environment for storing and accessing large data sets, while data mining techniques extract meaningful insights from this data. By leveraging both technologies, organizations can enhance their data-driven decision-making capabilities, uncover hidden opportunities, and improve overall operational efficiency. Big data and analytics. Big data and analytics are critical to understanding and leveraging vast amounts of information in today's data-driven world. They enable organizations to extract actionable insights, make informed decisions, and gain a competitive edge. Big data refers to extremely large datasets that are complex, high in volume, and generated at high velocity. These datasets are often too large and varied to be managed and processed by traditional data management tools. Big data comes from various sources, including social media, sensors, transactions, and weblogs. The sheer size and complexity of big data require advanced storage, processing, and analysis techniques. Analytics is the process of examining data to uncover patterns, correlations, and insights. It involves using statistical and computational methods to analyze data, draw conclusions, and support decision-making. There are different types of analytics, each serving a specific purpose. 1. Descriptive analytics. This type analyzes historical data to understand what has happened in the past. It involves summarizing data to identify trends and patterns, providing a clear picture of past performance. 2. Diagnostic analytics. This type seeks to understand why something happened. It involves drilling down into data to uncover root causes and correlations, offering insights into underlying issues and anomalies. 3. Predictive analytics. This type uses historical data and statistical models to forecast future outcomes. It helps organizations anticipate trends and make proactive decisions based on likely future scenarios. 4. Prescriptive analytics. This type goes beyond prediction to recommend actions that can influence future outcomes. It combines data analysis with optimization techniques to suggest the best course of action. The combination of big data and analytics enables organizations to handle massive data sets and extract valuable insights. Advanced technologies like machine learning, artificial intelligence, and cloud computing play a significant role in this process. Machine learning algorithms can automatically identify patterns and make predictions based on big data. Artificial intelligence enhances the capability to analyze complex data sets and provide deeper insights. Cloud computing offers scalable storage and processing power, allowing organizations to handle and analyze large volumes of data efficiently. Organizations use big data and analytics in various sectors, including healthcare, finance, marketing, and manufacturing. In healthcare, they improve patient outcomes by analyzing large data sets to identify patterns and trends in diseases and treatments. In finance, they enhance risk management and fraud detection by analyzing transactional data. In marketing, they enable personalized campaigns by understanding customer behavior and preferences. In manufacturing, they optimize production processes and supply chain management by analyzing operational data. Overall, big data and analytics are transforming how organizations operate and make decisions. By leveraging these technologies, organizations can gain deeper insights, improve efficiency, and drive innovation. The ability to analyze and act on big data is becoming increasingly vital in the competitive landscape, empowering organizations to stay ahead and achieve their goals. 5. Cybersecurity essentials. Cybersecurity is a critical aspect of modern information technology, focusing on protecting systems, networks, and data from cyber threats. As cyber attacks become more sophisticated and prevalent, understanding and implementing robust cybersecurity measures is essential for individuals and organizations alike. Understanding cybersecurity. Cybersecurity is the practice of protecting systems, networks, and data from digital attacks, unauthorized access, and damage. It combines technologies, processes, and controls to safeguard the integrity, confidentiality, and availability of information. As cyber threats become more sophisticated, effective cybersecurity measures are essential for individuals, businesses, and governments. At its core, cybersecurity aims to protect three primary aspects of information security: confidentiality, integrity, and availability. Confidentiality ensures that sensitive information is accessed only by authorized individuals through measures like encryption, access controls, and authentication protocols. Integrity maintains the accuracy and completeness of data, protecting it from unauthorized alteration and ensuring its reliability. Availability ensures that information and systems are accessible when needed, protecting against disruptions like cyber attacks, natural disasters, or hardware failures. Cyber threats come in various forms, each posing unique challenges. Malware, for instance, is malicious software designed to damage or disrupt systems, with common types including viruses, worms, ransomware, and spyware. Phishing involves deceptive attempts to obtain sensitive information by masquerading as a trustworthy entity. Denial of service attacks overwhelm a system or network with traffic to make it unavailable to users. Man-in-the-middle attacks intercept communication between two parties to steal or alter information. SQL injection exploits vulnerabilities in an application's software by inserting malicious SQL code into a query. To protect against these and other cyber threats, various cybersecurity measures are implemented. Firewalls act as barriers between trusted and untrusted networks, controlling traffic based on security rules. Antivirus and anti-malware software detect and remove malicious software from systems. Encryption protects data by converting it into a coded format that only authorized parties can read. Multi-factor authentication, or MFA, enhances security by requiring multiple forms of verification before granting access. Regular software updates and patch management protect systems against known vulnerabilities by keeping software up to date. Security awareness training educates users about common cyber threats and best practices, reducing the risk of human error. Despite preventive measures, breaches can still occur, making an effective incident response plan crucial for minimizing damage and restoring normal operations. This involves preparing an incident response team, monitoring systems for signs of breach, analyzing the nature and extent of incidents, implementing measures to contain and remove threats, and restoring systems to normal operation. Post-incident review analyzes incidents to identify lessons learned and improve future responses. In summary, cybersecurity is a multifaceted discipline that involves protecting systems, networks, and data from a wide range of cyber threats. By implementing robust security measures and maintaining a proactive approach to threat detection and response, individuals and organizations can safeguard their digital assets and ensure the continued integrity, confidentiality, and availability of their information. Common threats and vulnerabilities. Common threats and vulnerabilities in cybersecurity pose significant risks to the integrity, confidentiality, and availability of information systems. Understanding these threats and vulnerabilities is crucial for developing effective defense strategies and protecting digital assets. Common cyber threats. Malware, or malicious software, is designed to damage or disrupt systems. This category includes viruses, which attach to clean files and spread to other files, and worms, which exploit vulnerabilities to infect entire networks. Ransomware encrypts files and demands payment for their release, while spyware secretly monitors user activities to collect sensitive information. Phishing is a social engineering attack where attackers masquerade as trustworthy entities to deceive individuals into providing sensitive information such as passwords and credit card numbers. These attacks often occur through email, where the attacker sends a message that appears legitimate, tricking the recipient into clicking a malicious link or downloading an affected attachment. Denial of service and distributed denial of service attacks aim to overwhelm a system or network with excessive traffic, rendering it unavailable to users. These attacks can disrupt business operations, cause financial losses, and damage reputations. Man-in-the-middle attacks occur when an attacker intercepts and alters communication between two parties without their knowledge. This allows the attacker to steal sensitive information, such as login credentials, or inject malicious content into the communication. SQL injection is a technique where attackers exploit vulnerabilities in an application's software by inserting malicious SQL code into a query. This can allow unauthorized access to the database, leading to data theft, data loss, and unauthorized administrative access. Common vulnerabilities. Outdated software and unpatched systems are significant vulnerabilities. Attackers often exploit known vulnerabilities in software that has not been updated or patched, gaining access to systems and data. Keeping software up to date with the latest security patches is essential to mitigate this risk. Weak passwords and poor authentication practices are another common vulnerability. Attackers can easily guess or crack weak passwords, especially if users reuse passwords across multiple sites or services. Implementing strong passwords policies and multi-factor authentication can significantly reduce this risk. Misconfigured systems and networks can expose sensitive information and create entry points for attackers. Common misconfigurations include improperly set access controls, default credentials, and unprotected directories. Regularly auditing and properly configuring systems and networks can help mitigate this vulnerability. Insider threats pose a significant risk, as individuals within an organization may intentionally or unintentionally cause harm. This can include employees, contractors, or business partners who have access to sensitive information. Implementing strict access controls, monitoring user activity, and providing security awareness training can help mitigate the risk of insider threats. Social engineering exploits human psychology to manipulate individuals into divulging confidential information or performing actions that compromise security. This can include tactics like pretexting, baiting, and tailgating. Educating users about social engineering techniques and promoting a culture of security awareness are crucial defenses against such attacks. Seeing common threats and vulnerabilities is vital for protecting information systems. By staying informed about the latest threats, maintaining robust security practices, and fostering a culture of awareness and vigilance, organizations can better defend against cyber attacks and safeguard their digital assets. Security measures and best practices. Security measures and best practices are crucial for protecting information systems, defending against cyber threats, and ensuring the confidentiality, integrity, and availability of data. Firstly, organizations should conduct regular risk assessments to identify potential vulnerabilities and threats to their information systems. This involves evaluating the likelihood and potential impact of various security risks and prioritizing mitigation efforts accordingly. Developing and enforcing comprehensive security policies and procedures is essential. These policies should outline acceptable use, data handling, access controls, incident response, and other security-related practices. It's vital that all employees, contractors, and third-party vendors are aware of and adhere to these policies. Access control plays a critical role in security. Implement strong access controls to restrict access to sensitive data and systems. This includes using principles of least privilege and implementing multi-factor authentication for added security. Data encryption should be utilized to protect sensitive data both at rest and in transit. Encryption algorithms and protocols should secure data stored on servers, databases, and mobile devices, as well as data transmitted over networks. Keeping all software, operating systems, and applications up to date with the latest security patches and updates is crucial. Regularly installing security updates helps address known vulnerabilities and protects against exploitation by cyber attackers. Robust network security measures should be implemented, including firewalls, intrusion detection and prevention systems, and network segmentation. Encryption protocols like security sockets layer and transport layer security should secure network communications. Ongoing security awareness training should be provided to employees to educate them about common cyber threats, phishing scams, social engineering tactics, and best practices for maintaining security. Employees should be encouraged to report suspicious activities or incidents promptly. Having an incident response plan in place is vital. This plan should be regularly tested to ensure its effectiveness in responding to and mitigating security incidents. Clear procedures for detecting, reporting, investigating, containing, and recovering from security breaches or cyber attacks should be established. Regular data backups should be implemented to ensure that critical data can be recovered in the event of data loss, corruption, or ransomware attacks. Backups should be stored securely off-site, and backup and recovery procedures should be regularly tested to verify their effectiveness. Evaluation of the security practices of third-party vendors and service providers is important. Ensure that vendors adhere to security standards and contractual obligations to protect sensitive information. Continuous monitoring and logging of system activities should be implemented to detect and respond to security incidents in real time. Security information and event management systems should be used to aggregate and analyze security logs for suspicious activities. Finally, organizations should stay informed about relevant security regulations, compliance standards, and industry best practices. Ensuring compliance with applicable laws and regulations governing data protection, privacy, and security is essential. By implementing these security measures and best practices, organizations can enhance their overall cybersecurity posture, mitigate security risks, and protect sensitive information from cyber threats. Regular review and update of security measures are necessary to adapt to evolving threats and changes in technology and business requirements. Legal and ethical issues in cybersecurity. Legal and ethical considerations are pivotal in cybersecurity, requiring adherence to laws and regulations alongside ethical principles. Compliance with data protection laws like GDPR and CCPA is essential, ensuring transparency and individual rights. Industry-specific regulations such as HIPAA and PCI DSS set standards for safeguarding sensitive information. Protecting intellectual property rights, adhering to cybercrime laws, and fulfilling contractual obligations are also imperative. Ethically, respecting privacy rights, ensuring transparency, and promoting fairness and equity are paramount. Organizations must transparently communicate security measures and adhere to responsible data collection practices. Ethical hacking, responsible vulnerability disclosure, and social responsibility in cybersecurity education and collaboration are crucial for fostering trust and mitigating risks. By integrating legal compliance and ethical standards into cybersecurity practices, organizations can uphold integrity, protect privacy, and navigate the digital landscape responsibly. Part 2. Management of Information Systems. 6. Information systems in organizations. Information systems play a vital role in modern organizations, facilitating efficient operations, decision-making, and strategic planning. These systems integrate people, processes, data, and technology to support various business functions and objectives. Types of information systems. Information systems in organizations encompass various types, each serving distinct purposes and supporting specific functions within the organization. Here are the main types. Transaction Processing Systems, or TPS. Transaction processing systems capture, process, and store transactional data generated by business operations. They automate routine transactions such as sales, inventory, and payroll processing, ensuring accuracy and efficiency in daily operations. Management Information Systems. Management information systems provide managers and decision makers with summarized, structured information to support operational and tactical decision-making. They generate reports, analyses, and forecasts based on aggregated data from various sources within the organization. Decision support systems. Decision support systems assist managers in making semi-structured or unstructured decisions by analyzing data and providing insights and recommendations. Decision support systems leverage analytical models, simulations, and data visualization tools to facilitate decision-making. Executive Information Systems, or EIS. Executive Information Systems are specialized information systems designed to support strategic decision-making at the executive level. EIS provide top executives with access to summarized, real-time data and key performance indicators to monitor organizational performance and trends. Enterprise Resource Planning Systems. Enterprise Resource Planning Systems integrate core business processes and functions across various departments and locations within an organization. They streamline operations, optimize resource allocation, and improve collaboration by providing a centralized database and standardized workflows. Customer Relationship Management Systems, or CRM systems. Customer Relationship Management Systems manage interactions with customers and prospects throughout the customer lifecycle. CRM systems track customer interactions, manage sales pipelines, and facilitate marketing campaigns to enhance customer satisfaction and loyalty. Supply Chain Management Systems, or SCM systems. Supply chain management systems oversee the flow of goods, services, and information across the supply chain, from raw material sourcing to product delivery. SCM systems optimize inventory levels, streamline logistics, and improve collaboration with suppliers and partners. Knowledge Management Systems, or KMS. Knowledge management systems capture, store, and share organizational knowledge and expertise to facilitate learning and innovation. KMS include document management systems, collaboration platforms, and expertise directories to support knowledge creation and dissemination. Business Intelligence Systems, or BI systems. Business intelligence systems analyze and visualize data to uncover actionable insights and trends, enabling data-driven decision-making. BI systems incorporate reporting, analytics, and data visualization tools to transform raw data into meaningful information for stakeholders. Geographic Information Systems, or GIS. Geographic Information Systems capture, store, analyze, and display geographic data to support spatial analysis and decision-making. GIS integrate maps, satellite imagery, and location-based data to solve complex problems in various domains such as urban planning, environmental management, and logistics. These types of information systems work together to support organizational goals, streamline processes, enhance decision-making, and gain a competitive advantage in today's dynamic business environment. Role of information systems in business processes. Information systems play a crucial role in enhancing and optimizing business processes across all functional areas within an organization. Here's how information systems contribute to various aspects of business processes. Automation. Information systems automate repetitive tasks and transactions, reducing manual effort and human error. For example, transaction processing systems automate routine transactions like sales orders and inventory management, improving efficiency and accuracy. Data management. Information systems capture, store, process, and manage vast amounts of data generated by business operations. They ensure data integrity, security, and availability, facilitating informed decision-making and strategic planning. Streamlining operations. Enterprise resource planning systems, or ERP systems, integrate core business processes and functions across departments, streamlining operations and standardizing workflows. ERP systems enable seamless communication and collaboration, leading to improved productivity and efficiency. Enhanced communication. Information systems facilitate communication and collaboration among employees, departments, and external stakeholders. Collaboration tools, intranets, and enterprise social networks enable real-time communication, knowledge sharing, and teamwork, fostering innovation and agility. Decision support. Decision support systems, or DSS, provide managers with timely, relevant information and analytical tools to support decision-making. DSS analyze data, generate reports, and provide insights and recommendations to help managers make informed decisions. Customer Relationship Management, or CRM. CRM systems manage interactions with customers throughout the customer lifecycle, from prospecting to post-sales support. CRM systems track customer interactions, manage sales pipelines, and personalize marketing campaigns to enhance customer satisfaction and loyalty. Supply Chain Management, or SCM. SCM systems optimize the flow of goods, services, and information across the supply chain, from raw material sourcing to product delivery. SCM systems improve inventory management, streamline logistics, and enhance collaboration with suppliers and partners. Strategic planning. Executive Information Systems, or EIS, provide top executives with summarized, real-time data and key performance indicators to monitor organizational performance and trends. EIS supports strategic planning and decision-making by providing insights into market trends, competitor analysis, and industry benchmarks. Innovation and adaptation. Knowledge Management Systems, or KMS, capture, store, and share organizational knowledge and expertise, fostering innovation and continuous improvement. KMS facilitate learning, problem-solving, and knowledge dissemination, enabling organizations to adapt to changing market conditions and emerging trends. Business Intelligence, or BI. BI systems analyze and visualize data to uncover actionable insights and trends, enabling data-driven decision-making. BI systems transform raw data into meaningful information for stakeholders, supporting performance monitoring, trend analysis, and forecasting. In summary, information systems play a pivotal role in optimizing business processes, enhancing communication and collaboration, supporting decision-making, and driving innovation and adaptability. By leveraging information systems effectively, organizations can gain a competitive edge, achieve operational excellence, and sustain long-term success in today's dynamic business environment. Strategic use of information systems. The strategic use of information systems involves harnessing technology to meet organizational objectives, gain a competitive edge, and create value for stakeholders. Here's how organizations employ information systems strategically. Strategic decision-making. Information systems provide timely, relevant data and analytics to support strategic decision-making at all levels. Executive Information Systems, or EIS, deliver real-time data and key performance indicators to top executives, aiding in strategic planning and performance monitoring. Business process innovation. Information systems drive business process innovation by automating tasks, streamlining operations, and enabling new work methods. Enterprise resource planning systems, for instance, standardize workflows and optimize resource allocation across departments. Customer relationship management. CRM systems help organizations build and maintain strong customer relationships by tracking interactions, managing sales pipelines, and personalizing marketing campaigns. They provide insights into customer needs and behaviors, fostering satisfaction and loyalty. Supply chain management optimization. SCM systems enhance the flow of goods, services, and information across the supply chain, from sourcing to delivery. They improve inventory management, reduce lead times, and enhance collaboration with suppliers, boosting efficiency and lowering costs. Market expansion. Information systems, such as e-commerce platforms and digital marketing initiatives, facilitate market expansion by reaching customers globally, increasing brand visibility, and driving sales growth. Data-driven innovation. BI and analytics systems uncover actionable insights from vast data sets, supporting performance monitoring, trend analysis, and forecasting. These systems empower decision makers with valuable information for informed decision-making. Organizational learning. Knowledge management systems capture, store, and share organizational knowledge and expertise, fostering innovation and continuous improvement. They enable organizations to leverage internal expertise, best practices, and lessons learned. Regulatory compliance. Information systems help organizations comply with regulations by ensuring data security, privacy, and governance. Compliance management systems track regulatory changes, manage compliance activities, and mitigate legal risks. Collaboration and agility. Collaboration tools and enterprise social networks promote communication and collaboration among employees, fostering knowledge sharing, teamwork, and innovation. These systems enhance organizational agility and responsiveness to market changes. Sustaining competitive advantage. Strategically leveraging information systems enables organizations to differentiate themselves in the marketplace. Whether through innovation, operational excellence, customer intimacy, or cost leadership, information systems help sustain a competitive advantage and create value. Summarized, the strategic use of information systems is essential for organizations to achieve their goals, adapt to market dynamics, and thrive in a competitive landscape. By aligning technology with business objectives, organizations can harness the full potential of information systems to drive innovation, enhance competitiveness, and create sustainable value. 7. Developing and implementing information systems. Developing and implementing information systems involves a structured process to design, build, and deploy technology solutions that meet the needs of an organization. System Development Lifecycle, or SDLC. The System Development Lifecycle, or SDLC, is a structured approach used to design, develop, implement, and maintain information systems. It consists of several phases, each with its own set of activities and deliverables. Here's an overview of the typical phases in the SDLC. Planning. In this initial phase, the project scope, objectives, requirements, and feasibility are determined. This involves conducting a feasibility study to assess technical, economic, operational, and scheduling feasibility. A project plan is developed, outlining the resources, timeline, budget, and deliverables. Analysis. During the analysis phase, the current system and its shortcomings are thoroughly evaluated. Business requirements are documented and user needs are identified through interviews, surveys, and observations. The goal is to understand the problem domain and define system requirements. Design. In the design phase, the system architecture, data structures, interfaces, and functionalities are planned. This involves creating system and database designs, specifying hardware and software requirements, and developing prototypes or mock-ups. The design phase ensures that the system meets the identified requirements and objectives. Implementation. The implementation phase involves building, coding, and testing the system according to the design specifications. Software developers write code, integrate components, and configure hardware and software. Unit testing, integration testing, and system testing are conducted to validate the functionality and performance of the system. Deployment. Once the system has been developed and tested, it is deployed or rolled out to users. This may involve installing software, configuring hardware, migrating data, and providing user training and support. The deployment phase ensures a smooth transition from the old system to the new one. Operation and maintenance. After deployment, the system enters the operation and maintenance phase. This involves monitoring system performance, addressing user feedback and issues, applying updates and patches, and performing routine maintenance tasks. The goal is to ensure the system operates effectively and meets ongoing business needs. Evaluation. Throughout the SDLC, evaluation and feedback are collected to assess the success of the project. This may include evaluating user satisfaction, system performance, adherence to requirements, and return on investment. Lessons learned are documented to inform future projects and improvements. The SDLC is a cyclical process, with each phase informing and influencing the next. It provides a systematic framework for managing and executing information system projects, ensuring that they are completed on time, within budget, and to the satisfaction of stakeholders. Agile and other development methodologies. Agile and other development methodologies are approaches used in software development to manage projects and deliver high-quality software efficiently. Here's an overview of Agile and some other methodologies. 1. Agile methodology. Agile is an iterative and incremental approach to software development that emphasizes flexibility, collaboration, and customer feedback. It breaks down the development process into small, manageable iterations called sprints, typically lasting 2 to 4 weeks. Agile methodologies such as Scrum, Kanban, and Extreme Programming, or XP, prioritize customer satisfaction, adaptability to change, and continuous improvement. 2. Scrum. Scrum is a popular agile framework that defines roles, events, and artifacts to structure the development process. It involves cross-functional teams working collaboratively in short iterations to deliver potentially shippable increments of software. Scrum roles include product owner, Scrum master, and development team, with key events like sprint planning, daily stand-ups, sprint reviews, and retrospectives. 3. Kanban. Kanban is an agile methodology focused on visualizing and managing work using a Kanban board. Work items are represented as cards on the board, moving through columns that represent different stages of the workflow. Kanban emphasizes workflow optimization, limiting work in progress, and continuous delivery. 4. Extreme Programming, or XP. Extreme Programming, or XP, is an agile methodology that emphasizes technical excellence, rapid feedback, and continuous improvements. XP practices include test-driven development, pair programming, continuous integration, and refactoring. XP aims to deliver high-quality software that meets changing customer requirements. 5. Waterfall methodology. Waterfall is a traditional sequential approach to software development, where each phase, requirements, design, implementation, testing, deployment, is completed sequentially and the next phase begins only after the previous one is finished. Waterfall is less flexible and adaptable to change compared to agile methodologies, but may be suitable for projects with well-defined requirements and stable environments. 6. Iterative and incremental development, or ID. Iterative and incremental development, or IID, is an approach where the development process is divided into small, incremental iterations. Each iteration produces a working version of the software, allowing for feedback and adjustments throughout the development cycle. IID combines elements of both agile and waterfall methodologies, offering flexibility and adaptability while maintaining some level of predictability. 7. DevOps. DevOps is a culture, philosophy, and set of practices that emphasizes collaboration, automation, and continuous delivery between development and operations teams. DevOps aims to shorten the software development lifecycle, increase deployment frequency, and improve the quality and reliability of software releases. Each development methodology has its advantages and is suited to different project types, team dynamics, and organizational cultures. The choice of methodology depends on factors such as project requirements, timeline, budget, and stakeholder preferences. Project management for IT projects. Project management for IT projects involves planning, organizing, and coordinating resources and activities to deliver IT solutions within scope, on time, and within budget. Here's an overview of key aspects of project management for IT projects. 1. Initiation. In the initiation phase, the project is defined and authorized. This involves identifying the project's objectives, scope, stakeholders, and constraints. A project charter is typically created to formalize the project's initiation and obtain approval from stakeholders. 2. Planning. Planning involves developing a comprehensive project plan that outlines the project's scope, schedule, budget, resources, risks, and quality criteria. The project manager works with the project team and stakeholders to create a detailed work breakdown structure, schedule, and budget estimates. Risk management and communication plans are also developed during this phase. 3. Execution. Execution is the phase where the project plan is put into action. The project team performs the work defined in the project plan, including developing software, configuring hardware, testing, and implementing solutions. The project manager monitors progress, manages resources, and addresses any issues or changes that arise during execution. 4. Monitoring and controlling. Monitoring and controlling involve tracking project performance against the project plan, identifying variances, and taking corrective action as needed. Progress is regularly reviewed and changes to scope, schedule, or budget are managed through change control processes. Quality assurance and risk management activities continue throughout this phase. 5. Closing. Closing is the final phase of the project, where deliverables are formally accepted by stakeholders and the project is closed out. This involves conducting final inspections, obtaining sign-off on deliverables, and transitioning the solution to operations and maintenance teams. Lessons learned are documented, and project closure activities, such as archiving project documentation and releasing project resources, are completed. Effective project management for IT projects requires strong leadership, communication, and technical skills. Project managers must effectively manage stakeholders, allocate resources, mitigate risks, and adapt to changing requirements and priorities. They must also ensure that projects are delivered on time, within budget, and to the satisfaction of stakeholders. By following a structured project management approach, organizations can increase the likelihood of project success and achieve their strategic objectives. 8. IT governance and compliance. IT governance and compliance are essential components of managing information technology within an organization. Principles of IT governance. Principles of IT governance are guiding principles that help organizations effectively manage and align their IT activities with business objectives. These principles include alignment with business goals. Ensure that IT strategies, investments, and resources are in line with the organization's overall business objectives and priorities. Value delivery. IT initiatives should deliver measurable value to the organization, whether through cost savings, revenue generation, improved efficiency, or enhanced customer satisfaction. Risk management. Implement robust risk management processes to identify, assess, and mitigate IT-related risks that could impact operations, reputation, or compliance. Resource optimization. Allocate IT resources efficiently and effectively to support business activities and maximize return on investment. Performance measurement. Establish key performance indicators and metrics to monitor and evaluate the performance of IT initiatives and ensure they meet established goals and objectives. Compliance and legal requirements. Ensure compliance with relevant laws, regulations, industry standards, and contractual obligations related to IT, including data security, privacy, and intellectual property. Transparency and accountability. Define clear roles, responsibilities, and decision-making processes to ensure transparency and accountability in IT governance practices. Continuous improvement. Foster a culture of continuous improvement, innovation, and learning, where lessons learned from past experiences are used to enhance future IT initiatives and processes. By adhering to these principles, organizations can establish effective IT governance frameworks that support strategic decision-making, mitigate risks, optimize resources, and drive business success. Regulatory requirements and compliance. Regulatory requirements and compliance are crucial considerations for organizations, especially in the realm of information technology. Regulatory requirements encompass laws, rules, and standards established by government bodies and regulatory agencies to govern specific industries or aspects of business operations. These regulations vary depending on the industry, jurisdiction, and organization type. Examples include data protection and privacy laws like the General Data Protection Regulation, or GDPR, and the Health Insurance Portability and Accountability Act, or HIPAA. Cybersecurity regulations, such as the Payment Card Industry Data Security Standard, or PCI DSS, financial regulations like the Sarbanes-Oxley Act, or SOX, and telecommunications regulations covering spectrum allocation and network security. Compliance involves adhering to these regulatory requirements, standards, and best practices relevant to an organization's operations. Achieving compliance requires implementing policies, procedures, and controls to ensure that the organization meets legal and regulatory obligations. This includes conducting risk assessments, developing and implementing policies and guidelines, providing training and awareness programs for employees, monitoring compliance, reporting violations or incidents, conducting audits and reviews, and taking corrective actions when violations occur. Ensuring regulatory compliance is essential for mitigating legal and financial risks, protecting sensitive information, and maintaining trust with customers, partners, and stakeholders. By staying informed about regulatory requirements, implementing effective compliance measures, and fostering a culture of compliance, organizations can navigate regulatory challenges and demonstrate their commitment to responsible business practices. Risk management and IT audit. Risk management and IT audit are crucial components of information technology governance and compliance. Risk management involves identifying, assessing, and mitigating risks that could impact an organization's IT infrastructure, systems, and data. The goal is to proactively manage risks to minimize potential negative impacts on business operations, reputation, and compliance. This includes identifying potential risks and vulnerabilities related to IT systems, processes, and assets, evaluating their likelihood and potential impact, and developing and implementing controls, policies, and procedures to mitigate them. Continuously monitoring and reviewing the effectiveness of risk mitigation measures is also essential. IT audit, on the other hand, is an independent examination of an organization's IT systems, processes, and controls to assess their effectiveness, compliance with regulations, and alignment with best practices. IT audits help identify weaknesses, gaps, and areas for improvement in IT governance, risk management, and compliance. This includes evaluating compliance with relevant laws, regulations, and organizational policies, assessing the design and effectiveness of IT controls, and communicating audit findings and recommendations to management and stakeholders. By effectively managing risks and conducting IT audits, organizations can enhance their IT governance practices, strengthen their cybersecurity posture, and ensure compliance with regulatory requirements and industry standards. This helps safeguard the organization's assets, reputation, and overall business resilience. 9. Enterprise systems and applications. Enterprise systems and applications are software solutions designed to support the core functions and processes of an organization. Enterprise Resource Planning, or ERP. Enterprise Resource Planning, or ERP systems, are integrated software platforms that enable organizations to manage and automate a wide range of business processes across multiple departments and functions. These systems typically include modules for functions such as finance, human resources, supply chain management, customer relationship management, manufacturing, and inventory management. Key features of ERP systems include integration, automation, standardization, real-time reporting, scalability, and customization. These systems integrate data and processes across various departments, automate routine tasks, standardize business processes, provide real-time access to information, scale to accommodate organizational growth, and can be customized to meet specific industry and organizational requirements. Popular ERP vendors include SAP or SAP, Oracle, Microsoft Dynamics, and Infor, among others. Implementing an ERP system requires careful planning, customization, training, and ongoing support to ensure successful adoption and integration into the organization's operations. ERP systems play a critical role in improving operational efficiency, enhancing decision-making, and driving business growth and competitiveness. Customer Relationship Management, or CRM. Customer Relationship Management, or CRM, is a strategy and technology used by organizations to manage and analyze interactions with current and potential customers. The goal of CRM is to improve customer relationships, enhance customer satisfaction, and drive sales growth and profitability. CRM systems typically include features such as contact management, sales automation, lead tracking, marketing automation, and customer service and support. These systems help organizations streamline their sales and marketing processes, track customer interactions across multiple channels, and provide insights into customer behavior and preferences. Key benefits of CRM include improved customer relationships, enhanced sales and marketing effectiveness, better customer service, increased efficiency and productivity, and data-driven insights for strategic decision-making and business growth. Popular CRM software vendors include Salesforce, Microsoft Dynamics 365, Zoho CRM, and HubSpot CRM, among others. Implementing a CRM system requires careful planning, customization, training, and ongoing support to ensure successful adoption and integration into the organization's operations. CRM systems play a critical role in helping organizations build and maintain strong customer relationships, drive revenue growth, and achieve competitive advantage in today's market. Supply chain management, or SCM. Supply chain management, or SCM, is the process of managing the flow of goods, services, information, and finances as they move from suppliers to manufacturers to wholesalers to retailers to consumers. The goal of SCM is to optimize the supply chain by coordinating and synchronizing activities across all stages, from procurement of raw materials to delivery of finished products to customers. SCM encompasses various activities, including procurement, production planning, inventory management, logistics, demand planning and forecasting, supplier relationship management, and risk management. These activities are essential for ensuring the efficient and effective operation of the supply chain and for meeting customer demand while minimizing costs and maximizing profitability. SCM relies on information technology systems such as Enterprise Resource Planning, or ERP, warehouse management systems, transportation management systems, and advanced planning and scheduling software to automate and optimize supply chain processes. Effective SCM enables organizations to improve operational efficiency, reduce costs, increase customer satisfaction, and gain a competitive advantage in the marketplace. By streamlining supply chain processes, enhancing visibility and transparency, and fostering collaboration with suppliers and partners, organizations can achieve greater agility and resilience in responding to market dynamics and customer needs. Integration of enterprise systems. Integration of enterprise systems involves connecting and synchronizing different software applications and systems used across various departments and functions within an organization. The goal is to streamline business processes, improve data sharing and communication, and enhance operational efficiency and productivity. This integration typically includes connecting enterprise resource planning systems, which centralize data and automate core business processes such as finance, human resources, supply chain management, and manufacturing. Additionally, customer relationship management systems are integrated to manage customer interactions and relationships. Supply chain management systems optimize the flow of goods, services, and information across the supply chain, and business intelligence and analytics systems analyze and visualize data for strategic decision-making. E-commerce and digital commerce platforms are integrated to facilitate online sales and transactions, while collaboration and communication tools enhance communication and collaboration among employees, partners, and stakeholders. Integration methods include application programming interfaces, or APIs, middleware, data integration platforms, and enterprise service buses. Successful integration requires careful planning, coordination, and collaboration among IT teams, business stakeholders, and software vendors to ensure compatibility, data integrity, and security. Overall, integration of enterprise systems enables organizations to streamline business processes, improve decision-making, enhance customer satisfaction, and gain a competitive edge in today's digital economy. 10. Managing IT infrastructure. In this chapter, we will go over some IT management elements. IT infrastructure components. IT infrastructure components are the fundamental elements required to deliver IT services within an organization. These components form the backbone of any IT environment, supporting everything from basic computing needs to complex data processing tasks. The primary components of IT infrastructure include hardware, which encompasses servers, storage devices, network equipment, and end-user devices. Servers are powerful computers that provide resources, data, and services to other computers over a network. Storage devices are systems that store data, such as hard drives, SSDs, and storage area networks, or SAN. Networking equipment includes routers, switches, firewalls, and other devices that facilitate network connectivity and security. End-user devices include desktops, laptops, tablets, and smartphones used by individuals to access IT services. Software is another critical component, including operating systems, enterprise applications, and database management systems. Operating systems manage hardware resources and provide services for application software such as Windows, Linux, and Mac OS. Enterprise applications support business functions such as ERP or Enterprise Resource Planning, CRM or Customer Relationship Management, and HRM, Human Resource Management. Database management systems manage and organize data, examples being SQL and Oracle. Networking is a crucial aspect of IT infrastructure, involving local area networks, or LAN, wide area networks, or WAN, and internet connectivity. A LAN is a network within a small geographic area, such as an office building, while a WAN covers a broad geographic area connecting multiple LANs. Internet connectivity provides external connections to the global internet. Data centers are integral to the IT infrastructure, comprising physical facilities that house servers and storage devices. These centers require power supply systems for providing and managing electricity, including backup generators and uninterruptible power sources, or UPS. Cooling systems are also necessary to manage the temperature and humidity of data centers to prevent overheating. Cloud services have become an essential part of IT infrastructure, offering infrastructure as a service, platform as a service, and software as a service. Internet as a service provides virtualized computing resources over the internet. Platform as a service offers platforms for developing, running, and managing applications. And software as a service delivers software applications over the internet. Security components are vital for protecting IT infrastructure, including firewalls, antivirus or anti-malware software, encryption tools, and intrusion detection or prevention systems. Firewalls control incoming and outgoing network traffic based on security rules, while antivirus or anti-malware programs detect and remove malicious software. Encryption tools protect data by converting it into a secure format, and intrusion detection or prevention systems monitor network traffic for suspicious activity and prevent unauthorized access. Support and management tools are necessary for maintaining IT infrastructure, including monitoring systems, configuration management, backup and recovery, and IT service management. Monitoring systems continuously check the performance and health of IT infrastructure, while configuration management tools manage the setup and configuration of IT components. Backup and recovery systems and software back up data and recover it in case of loss or failure. And IT service management frameworks and tools deliver and manage IT services such as ITIL. These components work together to ensure that an organization's IT infrastructure is robust, scalable, and capable of supporting its operational needs. Cloud computing and virtualization. Cloud computing and virtualization are two key technologies that have transformed the IT landscape, providing more efficient, scalable, and cost-effective solutions for businesses. Cloud computing is the delivery of various services over the internet, including storage, processing, and software. Instead of relying on local servers or personal devices, businesses and individuals can access and use these resources on demand from a cloud service provider. Cloud computing is categorized into three main service models. 1. Infrastructure as a Service, or IaaS. This model provides virtualized computing resources over the internet. IaaS offers scalable and flexible infrastructure, such as virtual machines, storage, and networks, enabling businesses to build and manage their own applications and services without worrying about physical hardware. Examples include Amazon Web Services, or AWS, Microsoft Azure, and Google Cloud Platform, or GCP. 2. Platform as a Service, PaaS. PaaS delivers a platform that allows developers to build, run, and manage applications without dealing with the underlying infrastructure. This service includes development tools, databases, and middleware, making it easier for developers to focus on writing code and deploying applications. Examples include Microsoft Azure App Service, Google App Engine, and Heroku. 3. Software as a Service, or SaaS. Software as a Service provides software applications over the internet, typically through a web browser. Users can access these applications without installing or maintaining any software locally. SaaS is commonly used for applications such as email, customer relationship management, or CRM, and enterprise resource planning, or ERP. Examples include Microsoft Office 365, Google Workspace, and Salesforce. Virtualization is a technology that allows the creation of virtual instances of physical resources, such as servers, storage devices, and networks. By using a hypervisor, virtualization enables multiple virtual machines, or VMs, to run on a single physical machine, each with its own operating system and applications. This technology provides several benefits. 1. Resource efficiency. Virtualization maximizes the utilization of physical hardware by running multiple VMs on a single server, reducing the need for additional physical servers and lowering operational costs. 2. Scalability and flexibility. Virtual machines can be easily scaled up or down based on demand, allowing businesses to adapt to changing workloads quickly. New VMs can be provisioned rapidly, enabling faster deployment of applications and services. 3. Isolation and security. Virtualization provides isolation between VMs, ensuring that issues in one VM do not affect others. This isolation enhances security and stability, as each VM operates independently. 4. Disaster recovery and backup. Virtual machines can be easily backed up, replicated, and restored, improving disaster recovery capabilities. In case of hardware failure, VMs can be migrated to another physical server with minimal downtime. The synergy between cloud computing and virtualization has revolutionized the way businesses manage their IT resources. Virtualization is a foundational technology for cloud computing, enabling the efficient allocation and management of virtual resources in the cloud. Together, these technologies offer scalable, flexible, and cost-effective solutions that drive innovation and efficiency in today's digital world. IT service management. IT service management is a comprehensive approach to designing, delivering, managing, and improving the way IT services are utilized within an organization. It aims to align IT services with the needs of the business, ensuring that they support and enhance business processes. IT service management encompasses a range of activities, policies, and processes to manage the end-to-end delivery of IT services. At the core of IT service management is the concept of service delivery, which focuses on ensuring that IT services are provided effectively and efficiently. This involves managing the entire life cycle of IT services, from their initial planning and design through to deployment, operation, and continual improvement. IT service management frameworks such as ITIL, or Information Technology Infrastructure Library, provide best practices and guidelines for implementing IT service management processes. One of the key aspects of IT service management is incident management, which involves identifying and resolving incidents to restore normal service operation as quickly as possible, minimizing the impact on business operations. Problem management, on the other hand, focuses on identifying the root cause of recurring incidents and implementing permanent solutions to prevent future occurrences. Change management is another critical process within IT service management, aimed at managing changes to IT services and infrastructure in a controlled and systematic manner. This ensures that changes are made with minimal disruption to existing services and that any potential risks are mitigated. Configuration management involves maintaining an accurate and up-to-date record of the IT assets and their configurations, which helps in understanding the relationships and dependencies between different components of the IT environment. Service level management is focused on defining, agreeing upon, and monitoring service level agreements, or SLAs, between the IT service provider and the business. This ensures that IT services meet the agreed upon performance and quality standards. Capacity management ensures that the IT infrastructure has the necessary resources to meet current and future demand, avoiding over-provisioning or under-provisioning of resources. Continual Service Improvement, or CSI, is an ongoing process that aims to identify and implement improvements to IT services and processes. This involves regularly reviewing performance data, customer feedback, and industry best practices to identify areas for enhancement. CSI helps in maintaining the relevance and effectiveness of IT services in a constantly changing business environment. IT service management also encompasses service desk functions, which serve as the single point of contact between the IT department and end users. The service desk handles requests for assistance, service requests, and incidents, providing timely support and resolution. Effective communication and coordination between the service desk and other IT service management processes are crucial for efficient service delivery. Overall, IT service management provides a structured approach to managing IT services, ensuring that they are aligned with business objectives, delivered efficiency, and continuously improved to meet evolving needs. By implementing IT service management best practices, organizations can enhance their IT service quality, increase customer satisfaction, and drive business success. You have been listening to Information Technology, Essentials and Management of Information Systems. Written by Phil Gilberts. Narrated by Kevin Brooker.